Well, hello. In this video, we are going to be reviewing how to multiply and divide fractions. So let's start out by looking at these examples. And again, you want to be taking good notes, so I would recommend writing down these examples and then using those to follow along with as we go through this. Because as you work on your assignment, you'll see some of these coming up in the next few days. So this first example, we have 2/7 times 14/5. Now, technically, if we wanted to, we could just multiply across from the begin with and take 2 times 14 and 7 times 5 and get 28 over 35. But then when we're working with fractions, we always have to make sure our answer is reduced. And for some of these problems, if you just did that for all of these, you'd be working with some really big fractions to reduce. So another technique is we could actually reduce before we multiply. So let's review how to do that. So when we look at 2/7 and 14/5, now 2/7 itself and 14/5 in and of itself don't reduce. But if we look diagonally, 7 and 14 are both divisible by 7. And so let's go ahead and do that. 7 divided by 7 is 1, 14 divided by 7 is 2. And now there's nothing else for me to reduce, and so now we would multiply these across from each other. So the numerators, 2 times 2 would be 4, and in the denominator, 1 times 5 would be 5. So now in the second fraction, or second example, we could technically, like I mentioned earlier, multiply all the numerators together, multiply all the denominators together, but that's going to end up in a really big fraction. And for one, I don't want to take 15 times 14 and then multiply that denominator by 3. Okay, so we want to look to see how we can reduce this before we start to do any multiplying. Now, I know that 3/15 could reduce, but 5/14 in and of itself doesn't reduce, and 7/3 doesn't reduce either. However, we can look diagonally between the numerators and denominators and look to see what could reduce. And like I said, I know 3/15 would reduce, but I want you to notice something else. I want you to notice that we have a 3 in one numerator, we have a 3 in the other denominator. So actually those two 3's we could also cancel out and say that 3 divided by 3 would be 1 for both of those. And then I would recognize that, well, wait a minute, 5 and 15 those are both divisible by 5. 5 goes into 5 one time, and 5 goes into 15 3 times. And then I notice that, well, 7/14, well, 7 goes into 7 one time, and 7 goes into 14 two times. So now we're going to multiply those numerators together. Well, the nice thing is 1 times 1 times 1 would just be 1 in the numerator, and in the denominator, 3 times 2 times 1 is simply 6. So those three fractions, to multiply them together, would give you 1/6. All right, I want you guys to try this third one on your own. So here we have 4/9, 35 over 12, and 18/7. And I want you to take a minute and simplify this as much as possible, and then multiply the numerators and denominators together. By the way, if you get an improper fraction, meaning your numerator is bigger than the denominator, you can leave it as an improper fraction. So I want you guys to go ahead and take a minute and work on this one on your own. And so pause the video and hit play when you're ready to check to see if you got the correct answer. All right, let's see how you did. So one thing you might have recognized is that 4 goes into 12 evenly. 4 goes into 4 one time. 4 goes into 12 3 times. What else did you notice? Did you notice that 7 goes into both 7 and 35? So 7 goes into 7 one time. And 7 times 5 is 35. So 7 goes into 35 5 times. And maybe you also recognize that 9 goes into 18. Now you might have thought, well, 3 goes into 9 and 3 goes into 18, which would work, but it's always best to use the largest number that goes into both of them. So in that way you don't have to reduce again. So 9 goes into 9 one time, 9 goes into 18 two times. And now when you multiply the numerators together, we end up getting 10/3. You always want to check and see if that could be reduced any further, because it might have been, like maybe if you had, instead of doing 9 goes into 18, if you had done 3 for that, you'd end up getting a fraction that would still be able to reduce further. So you always want to make sure that your final answer is completely reduced. All right, well, that's a review of multiplying fractions. Now, what about dividing fractions? Now, there's going to be two methods we're going to look at to dividing fractions. So, and we're going to use the same examples for both methods. So you guys get a chance to see both of them, and you can decide for yourself which method you prefer. So let's look at this first method. This first method is going to involve finding a common denominator. So if you look at 2/7 and 3/5, a common denominator there would be, the least common denominator would be 35. And if you're ever not sure of what would be the best common denominator to use, one way to do this is you could just multiply the two denominators together. That will always give you a denominator. It's not always going to be the least common denominator, but if you're ever stuck, you could always do that. And then if it wasn't the least common denominator, you'd just have to reduce your final answer. But here the least common denominator would be 35. So now what would I multiply 7 by to get, because we want to convert that 2/7 to be an equivalent fraction of something over 35. So what would I multiply 7 by to get 35? Well, that'd be 5. So we're going to multiply the numerator, the 2, by 5 as well, so we get 10 over 35. Then we do the same thing for the other fraction, except for now we're going to convert 3/5 into a fraction over 35. So what would I multiply 5 by to get 35? And that would be 7. So we're going to multiply the numerator by 7 as well. And 3 times 7 is 21. Now here's a cool thing about this method. So we have a common denominator. That denominator, we're not going to use it all in our final answer. What we're going to do is we're going to take that the numerator from the first fraction, we're going to put that in the numerator of our answer. We're going to put the numerator from our second fraction, and we're going to put that in the denominator. And your answer is 10 over 21. Like I said, you always want to check to see, can this reduce any further? 10 is an even number, so 2 works, but 21 is not an even number, so 2 doesn't go into 21. 3 goes into 21, but not 10, and so on. So 10 over 21 cannot be reduced, so that would be your final answer. Let's try another one together. Here we have 4/5 divided by 2/3. Again, we're looking for a common denominator. So the common denominator in this situation would be 15. So we want to convert each of those fractions to be a fraction over 15. And so in that first fraction, what would I multiply 5 by to get 15? Well, 5 times 3 is 15. So we multiply the 4 times 3, and 4 times 3 would give us 12. So those two are equivalent fractions. In the second fraction, we had 2/3, and now I want a fraction over 15. So what would I multiply 3 by to get 15? Well, that would be 5, and 2 times 5 would be 10. So again, we're going to take the numerator from that first fraction is going to be the numerator for our answer. The numerator from the second fraction is going to be in the denominator for our answer. So we'd end up getting 12/10. Do you notice something about this fraction? Hopefully you recognize that these are both even numbers and this can be reduced. So 2 goes into both 12 and 10 evenly to be 6/5. All right, why don't you guys try one on your own? Well, actually, for this one, we're going to start this one together, and then I'm going to have you try it on your own in just a minute. But here we have two mixed fractions that we're dividing. If you're ever working with mixed fractions, we want to convert them into improper fractions. So if you remember how to do that, we would take the denominator times the number on the outside times the numerator. I'm sorry, plus the numerator. So for that first fraction, we take 3 times 1 and then add the numerator plus 2. And when you do that, you'd get 5/3. For the second fraction, I would take 5 times 1, which is 5, add the numerator, which is 4, and I would get 9/5. All right, so here we have it set up the same way as the previous fractions were. So I want you guys to take a minute, and I want you guys to solve this one using this first method. We'll learn about a different method here in a minute. So go ahead and pause the video and try the rest of this one on your own. All right, let's see how you did. So you should have gotten 25/15 and 27/15 as your two equivalent fractions. And so when we take and get your answer would be 25 over 27. And those can't be reduced, so that is your final answer. All right, let's look at a second method. Now, the second method, like I said, it's completely different. It's a different technique. So what we're going to do, and this is the way that I learned, this would be a more traditional method. If we had 2/7 divided by 3/5, what we're going to do is we're going to change this to be multiplying by the reciprocal. Okay, so instead of dividing by 3/5, you take that second fraction and we flip it. That's what a reciprocal is. We don't hear that word too often. So anytime you hear that word reciprocal, it just means we take the fraction and flip it. So the reciprocal of 3/5 would be 5/3. And now what we've done by changing that reciprocal, we've changed this now to a multiplying problem. So now remember, we could just multiply these across, but first I want to look to see, like we learned about in the first part of the video, is there anything I can reduce here? And there isn't. So I multiply the numerators together and the denominators together, and I get 10 over 21. Let's look at that second example, the same example we saw earlier with that first method. So with this one, we're going to change, with the second method, we're going to change this to be multiplying by the reciprocal. So the reciprocal of 2/3 would be 3/2. Now I know you could just multiply these together and get 12/10, but if you remember from the previous example, we had to then reduce that answer. So we could do it that way and get 12/10. Otherwise, what we could do is we could see, can we reduce this at all before we multiply it? And maybe you recognize that the 4 and then one numerator and the 2 and the other denominator, those can be reduced because 2 goes into both of those. Nothing else can be reduced here. So we can multiply these together now and get 6/5. Do you see how that works? All right. So let's look at that last example. So again, we would change this to be from a mixed fraction to improper fraction, just like we did in the previous part of the video. But now from this part, you're going to multiply this by the reciprocal. So I want you guys to use this second method now to multiply these two fractions. All right, let's check to see how you did. So you should have changed this to be multiplying by the reciprocal. Now you might say that, ooh, there's 2 5s on top. Can we cancel those out? The only time that we can reduce is when we have things between the numerator and denominator that we can cancel out. So the 5 and 5, we wouldn't look there. Between the numerators and denominators, there's nothing we could cancel out. So we would just multiply the numerators and denominators together, and you get 25/27. Well, there you have it. That is a review of multiplying and dividing fractions. And so again, with dividing fractions, there's 2 different methods, and you get to pick which method you prefer. That's the beauty of math. I tell students oftentimes that just like in life, if I'm going to go from my house to the park, or my house to school, or to church, or to the shopping mall, there's multiple directions I could take. Depending on the time of day, I might, pick one direct set of directions over another based on traffic. Maybe there's an accident, so maybe I have to take a detour and go a different route. So there's multiple ways that you can get to the same destination. The same thing is true of math. There's a lot of times there's more than one way to get your answer, and oftentimes I'll show you multiple ways and let you pick the one that you prefer. So I hope one of those stood out to you and one of those that maybe you enjoyed over the other. But otherwise, I hope that this made more sense, and good luck now as you're working on that homework assignment.